Hi everybody, this is Cody Jackson for Codamom, and this is the fifth video in the Practical Information Technology series, and today we're going to be talking about computer memory. We're going to start with the basics of memory, specifically what is memory. Memory is the primary workspace for the CPU. It's basically non-permanent location to store data that is going to be used by the CPU as the data is being processed. So it's not your hard drive. It's a memory location within the computer where work gets done. So data is taken from the memory to the CPU, processed, and data is sent back to the to memory, and then when you save a file, it's copied from memory to your hard drive. So it is volatile, meaning once you lose power, all of that data that's in the memory is gone. So you need to move it to your hard drive or a solid state drive or other sort of permanent storage before shutdown. It's also one of the reasons why it's recommended to have an uninterruptible power supply, and UPS or UPS, for your computer, so that there's a few minutes of power available so you can gracefully shut down your computer and not lose any data that you're working on. So in the computer, there are two types of memory. There's SRAM and there's DRAM. ROM, which we talked about when we talked about the BIOS, is not normally considered part of the computer memory because it's only used during boot up, and then after that it's not really touched anymore. We'll talk about the details of SRAM and DRAM in a second. So RAM itself stands for random access memory. Basically, if you consider a audio tape, then that was a linear access memory form. Audio tape and reel-to-reel tape was actually used for computer memory for a long time. If you've ever seen old documentaries or old movies and they have the big computer banks with the big reel-to-reel magnetic tape in there, that was the memory that was being used. But it's linear. It can only go in one direction or the other, but it has to spin very far to get to a particular location, whereas random access is more like a CD or DVD, where it can almost instantaneously move to any location on that disk. So RAM is comparatively cheap while being quick to access, and I created an office analogy to help explain it to those who may not necessarily understand how everything aligns. So if you consider RAM to be your desk, then it's going to hold your most commonly used items. Your hard drive is going to be your filing cabinet. So it's not your immediate workspace, but it's close to your workspace, and it holds information that is infrequently used, or you're archiving it for storage purposes or something like that. It may be used sometime in the future, but you're not immediately accessing it. And then moving information between the filing cabinet and the desk includes a trip to the photocopier. So the data that's in memory is a copy of what's on your hard drive. So if you copy data from your hard drive into memory, it's a copy of it. It's not the actual data, and it's not until you save it back to the hard drive that you have replaced that data. So if you lose power and your RAM loses power, it's lost all of the data that you've changed in there, and you never saved it to your hard drive. So that's why the trip to the copier is put in there, because it's not just pulling data from the filing cabinet and putting it on your desk. In that case, you would not have another copy in your filing cabinet. You've made a copy and you put it on your desk, you work on it, and if somebody opens the window and all your paperwork flies out the window, you still have the original copy to work from. But whatever changes you've done to it is now gone. You have to recreate that. DRAM stands for dynamic RAM. This is the main computer memory for computers. So if you ever upgrade the memory in your computer, you are changing out the DRAM in your computer. It is composed of transistors with a capacitor associated with it. If the capacitor has a charge, then that gives you the binary 1. If the capacitor is not charged, then it's the binary 0. So you've heard how computers use ones and zeros. This is literally where that comes from. Is there a charge or is there not a charge? We have never talked about capacitors. We haven't talked about transistors. I'm actually going to start a basic electronics series, and we will talk about those in that in a little bit more depth if you want to get that far into it. If not, you can stay with this high-level stuff in this series. So, capacitors, in the most basic theme, are two plates of conducting material with some sort of a dielectric insulator in between those plates. Because those plates are not touching, they build up static charges on them. So think static electricity. When you're rubbing your feet on the carpet and you touch a door handle, there may be a small shock that you get. That's the same thing that's happening with a capacitor as it stores a charge. So because these capacitors are so small, it doesn't take a lot of time for the charge that's stored on the capacitor to dissipate. So that would be touching the door handle. So they are continually refreshed, the dynamic part of DRAM, on a periodic basis, approximately every 15 milliseconds, to maintain that charge. Basically what happens is the CPU is running along and it has to pause and then not perform any operations and allow the power system to go through and refresh whatever the state is of those capacitors. And that allows them to maintain what the ones and the zeros. You can change the refresh speed in a lot of computer systems by going into the CMOS and changing the configuration. But if you set it to go too long, and you would want it to be a longer time between refreshes, because that means that gives the computer more time to do operations before it pauses. If you go too long, though, you have the potential of losing the data that's in memory because that capacitor has lost its charge before the next refresh comes along. And so that's why most retail systems, most consumer systems, don't really allow you to mess with that, because you can ultimately lose data, and then you get frustrated at the manufacturer for that, not realizing that you were the one who did that. SRAM is static RAM. It's more expensive than DRAM because it's using actual electronics circuitry rather than just a capacitor to handle the 1 or the 0 state of the transistor. That uses flip-flop circuitry. Again, not going to go into that in here. Just recognize that you don't have a capacitor, which is very cheap. Like I said, it's just two conducting plates separated by some sort of an insulator. The flip-flop is generally about 4 transistors with some additional circuitry in there. So you're basically looking at 4 times the immediate cost of a single transistor with a capacitor. But because it doesn't have that capacitor that needs to be continually refreshed, it's much, much faster. So on the order of tenths of a nanosecond to work with versus milliseconds for a standard DRAM. Because it's so fast and because it's so expensive, this memory, SRAM, is more commonly used as cache memory. So if you remember when we were talking about CPUs, we talked about the level 1, level 2, level 3 caches. This is what's actually performing that cache storage of data, is your SRAM. Theoretically, you could create SRAM for a computer instead of DRAM and use SRAM for everything, but it's going to be prohibitively expensive once you start getting to very large sizes, capacities, I should say, because you have a lower density, because you have basically 4 times the electronics involved versus just a straight capacitor and transistor. So you're going to have less data storage on a larger chip. So that's why we don't have SRAM as our primary memory. So I just wanted to run over here and show you some examples of memory if you've never bothered to open a computer or look at them. So this picture here is a typical stick of dynamic RAM. You have your connectors right here. They are gold plated. If you remember, I think it was the first video we talked about how there's precious metals, primarily gold, in computers. This is one of the reasons, because it is part of the connectors. And gold is used because it's non-corrosive, so it's not going to deteriorate over time. It's not going to be affected by chemicals or anything like that. Obviously, you can still statically short out stuff if you put water on it, but it's not going to corrode in terms of getting a patina like copper does or brass. So anyways, these are the actual chips right here that hold the memory, and then they are individually connected via these traces that you see here to the pins that are connected to the motherboard itself. And every stick that you're going to get is going to have a information sticker on here that's going to tell you the speed and the size. So the speed is a PC 133, and then it's a 128 megabyte synchronous 133 megahertz CL3. So the refresh rate is a class 3. And it runs at 133 megahertz. So this is actually really old, but it's indicative of what you would normally see in a computer, regardless of whether it's a single-edged, double-edged, whatever. This is a SODIMM. This is basically the same thing, except it's used in laptops. It's probably about half the length, but you can see that it stacks the chips vertically to get that shortness. And so these are probably roughly palm-sized, the center of your palm, not your entire hand. But they function the exact same thing. Now, you may see that there's these little notches in the sticks, and that is a key that basically allows you or requires you to insert the memory into the computer in one way and one way only. It won't fit any other way. And that basically just ensures that the positive and negative terminals are in the correct locations, and you're not going to short anything out or anything like that. So here's a good comparison of a traditional desktop stick of memory and a SODIMM used in laptops. You can see it's roughly half the size. It doesn't mean that it has any less capacity because these are just higher density chips. In this case, however, reading the tag, you can see that this is a 512 megabytes versus 1 gig of RAM. This runs a little bit faster at 1333, whereas this is 1066. So that's it for this video. I just wanted to give you a basic overview of what memory is and high-level picture of how it works. And so that's basically what we did. We just talked about the purpose of memory, how the computer uses it, 2 main types of RAM in your computer. DRAM is what you can replace. SRAM you cannot touch because it's included in the CPU core package. So, we've talked about a lot of the basics of how computers worked. We haven't talked about everything like the peripherals, hard drive, stuff like that. But I want to take the next video and actually talk about how data is moved around the computer, interacts with the CPU, sits in memory, how it's addressed, and basically just show from a software side how computers actually work. So ignoring the hardware, but kind of looking at how the logic flow is. So I hope you enjoyed this video. I hope you learned something from it. If you have any questions or comments, please let us know in the comments section of YouTube. And until the next video, keep learning and keep having fun. Thanks.